So to keep the internet stable, I wouldn't be showing my face. So kindly bear with me today. So thank you so much. My name is Bilikisu Olatunji. I'll be the moderator for today. I'm a data scientist based here in Abuja, Nigeria. I'm the founder and the co-organizer of this group, Abuja R User Group. So today I'm going to be walking you through how to use tidymodels for machine learning, to creating models that can predict based on past data. We're going to use that to predict what we can get for the future. So in this case, we're going to take on a kind of simple linear regression using tidymodels. So I'll take us one by one through the steps. I'll explain as we move along. And if you have questions, just let me know in the chat. So, and I'll also seek the assistance of one of our co-organizers that is available here, Ifeoma Igboha. So she'll be on standby to look at the chat, and she'll be able to do that for me. So thank you so much all for joining. So let me go ahead and share my screen. Before we go into the coding properly, so this is going to be an interactive session. So you can ask questions, contribute, just put your questions in the chat box, then we'll be able to answer them as we go. It's going to be a beginner friendly, but at least we're going to follow the normal standards of creating models in R using the tidymodels. So I'm going to take you through some little introduction to the package itself. So this is the main website for tidymodels, where you can get more information into what it's all about. So tidymodels, as you can see on my screen. So tidymodels framework is a collection of packages for modeling and machine learning using tidyverse principles. So just like we're used to tidyverse has so many packages all bundled up as one single package. The same thing goes with tidymodels. Tidymodels comes with all these little but mighty packages. We're talking about R sample, parsnip, recipes, tune, yardstick, and so on. There are still some other ones that are also there. So just like we have for the tidyverse, you don't get to see most all, like 100% of all the packages that's inside the tidyverse. The same thing goes here. So they're adding more packages as the package evolves. So you can get more information from this web page. So it's just a framework that helps you to get away from the old school learning of creating models, where you use, maybe, let's say for the linear regression model, you use the LM function. That is where you start, and you continue to get so many packages you have to bundle up together or merge or stack together. But here, tidymodels. So I hope you can see my network is bad. If you cannot hear me, please kindly let me know. The network is bad, it's raining really heavily here. So just let me know if you cannot hear me. So the tidymodels package helps you to go step by step. It has everything you need to create a model, package your model, and bundle it so that you can use it to predict future or predict based on new data set that you're going to be working with. So tidymodels framework, or package as you might want to say, gives you all the functionalities, from cleaning your data to also kind of preparing your data, create a template for managing your data. So these packages all are made for different steps or stages in your model creation or building your model. So like this recipes package is going to help you to create some steps for preparing your data in a good shape for you to pass on to the model, whichever model you want to use. The same thing with our sample. This is going to help you to kind of split your data into the training and the testing data that you're going to use for your models. So we also have the tune. We're not going to go into this one, the yardstick. There's still some that are there. So if you want to get more information, or you want to start your learning of how to create models, you can come to this page. The get started page is there, where you go through some simple tutorials that will help you to learn more about tidy models. And you can see them here. They're broken down into simpler steps where you're starting with bringing in your data using the tidyverse package. You'll clean your data, modify it, reshape it as you want. Then you will now go to the level of, exploring your data. You explore your data, you get to understand which one is which, and then you can go straight ahead to creating your model, or you can go through some steps that could help you to modify your data for your model in particular, not just for analysis. So all these steps are steps that we're going to go through. And one thing I want you to have at the back of your mind is this. This is not a one-way procedure. It's iterative. If you start from bringing your data, modifying your data, prepping your data, like we always said before in the past, you bake your data, you prep your data, you fit your data to your model and all this stuff. All these things are technical stuff that are steps that leads you to creating a good enough model. It's not going to be perfect. But you have the opportunity to go back and go through the steps over and over again until you can get a perfect model. So it is not just a one-way traffic stuff. No, you have to be patient. You have to continue to work on your data to make it to be good enough for you to have a good model that will give you good predictions. So these are the things that you get to do with tidy models, and it makes it easy. So without wasting much of our time, let's go to RStudio. So I'm using RStudio instead of positron because from my own network, I think some people are still trying to get familiarized or get familiar with positron. So we'll still stay with RStudio. So this is our RStudio. I've created my project, and I think the only thing now is for me to bring in my data. So let me get my data into this. So this data is is a real data. It was scraped from a website. This is the cars45.com. So it's real legitimate data, and but there's no legitimacy in the sense that you still have to clean the data. So this is one thing I want you to understand. We'll still have to clean our data. So first thing is I will have to bring in the data. Let me bring in the script I prepared before, but I'll take you through one by one. So first, let me load the package. So first I will need tidyverse. Then we'll bring in the tidy models data. So let me save this demo. So let me load this too. So I'm going to be copying some data, some code, so that we don't take too long. Let me just add this to the code here. So we are using the schema package to explore our data. Like we want to do a kind of a quick summary statistics about our data. So if you're finished cleaning your data, you need to kind of do some little statistics or more for you to understand your data before you push it to any models that you want to use. Then VIP is for us to know the most important features, that is the columns that are inside our data that we can use to make our model better. So the last one is one of the models that we're going to be using. So other than the baseline model that we're going to create. So when we have all this ready, then I think we'll be good to go to bring in the data now. So here I'm importing data. So let me make it quick. And so I need to also set the seed here. So setting the seed is just to make sure that if I pass on the data and the code to you, you'll be able to have something consistent in all the steps that you're going to take. So it's more like it's going to lock up everything. So it's not going to be like a random data, because we're going to do some iterative stuff that we need it to be stable so that everything is consistent as we go through all the steps that we're going to be using. No matter the number that you're putting in here, it doesn't matter. I can put in more than this and anything you want. You just make sure it's numbers. Then this would give you something kind of a stabilized environment also. So I just want to use the layman's term as much as I can. So, but if you're getting lost or something, just let me know in the chat. Then I'll be able to answer some questions. So the next thing is that we're going to use from the tidyverse package, we're going to get a function that is the read_CSV. There's a package within tidyverse, we call it the readr. So this is going to be the one that is going to help get this function, and that's read_CSV. So that's what we're using here. So let me comment that out. So we'll bring in the data because the data is inside this folder, and that is it. So we'll just we are reading in data from CSV. So this goes in there. And now I have something in my environment here in this box that shows you there is a data element here. So a data object. So we're having how many rows here? We have 3,477. 477, then we have 19 variables, that's 19 columns. We can explore this or look at it by clicking on the name. So now we have so many columns here that we would want to make maybe just some decisions on all the columns, because we wouldn't need all of them. Most of them are not what we need, and most of them are having information that are being kind of duplicated all over. So that is why we would have to drop some of these columns. Okay. So I'm going to share everything. So if I keep moving in and out of the session, I'm going to share the data. What I want you to do now is just focus on getting something from what I will say. So then you can now practice on your own later. I'll give you the data set. Okay. So, and the code as well. So that is something that I would say now. So let's have a glimpse of the data. So if I open it up, so we have all these columns. We have 19 columns. The listing ID is not going to be useful to us for now. So then the title as well is if we're talking about machine learning, we don't want leakages, because Toyota Corolla 2004 Gold, there are information that are also inside of this. You can see the column here, Toyota. You can see Toyota, the first thing here is there. So then Corolla is there in the model column. Then 2004 is within the year column. So we're going to drop this first too. So we don't want leakages all around. So then you can see gold, that's the color is also here. So we wouldn't want to be repeating stuff because that's going to be a lot for our model to handle. And it's going to kind of cause confusion somehow. So in layman's term, give it the most important features or columns, give your model the most important features or columns that could help it to make the right prediction. That's the main thing about creating or going through predictive models, in short. So that is one thing. So as we look at this, we'll see that there are so many things going on here. Like this price formatted is basically for the website. So we wouldn't need it because we cannot do anything like arithmetic operation with it. So we would have to drop that. Then the next column, we are seeing this, there's some missing values here, but we're going to decide if we're keeping it or not. The same thing with the for type. We're going to look at the number of missing values there so that we'll be able to decide, is it worth keeping or not? So we also have condition, engine size, location, state, city, tags. The tags here has some information that are very, very critical that could help our model. So we have the local use. We already have that here in the condition column. But I've explored the data, so I know that this column has some missing values. Whereas if we go to the next stage, you'll say that when we split this column, that is where we're manipulating we're cleaning our data, because this takes, like the saying says, 80% of your job as a data scientist or a data analyst. Clean your data and get it into a good shape for any further exploration. So if we split this, we get like 100% of the information here, whereas this one is not complete. So the last one, selling condition, then bought condition, we're going to see why we need to keep them or not. So let me go back to the code now. So I would pick up this. So now we need to split the tags. So I'll just copy this and push into the demo file. So we're still cleaning the data. We're not getting into modeling or anything, nothing for now. So we have the data and we've seen that we have a special column there that we need to do something about. And what we want to do is we want to split it. That's the tags column. Another thing you have to understand is that there are columns already in the data set that has the same name. So for me not to, or for us not to get into any issues, we're going to precede the name, although we're going to have the same name, with tags underscore condition. The name of your column doesn't have anything to do with your model. It's the data or the values that are inside that column or the feature. That is the most important thing. So I can give it any name I want, provided it makes sense to me or to my colleague that I'm working with or somebody else that is going to use the code. So this is where we're going to use this function separate. So we're taking that column tags and we're breaking it into 3 columns. So each of these columns that we're going to create is being separate. You can get the values for each of these columns from the value before the comma. So let me open this up. So if you look at this, this is the tags column. So you can see local used is for the tags condition, then automatic is for the transmission, while the last part is for the mileage. So that is why. So and comma is what separates each of the values. So that's why we're putting it in here for this option. So then we're filling towards the right. That means if we didn't get any value for any of these columns, especially it's going to be the last one, then we would just fill it up like it's blank, not NS. So then we'll The last one is extra, that's merge. So whichever, if we have more than 3 values in any of the rows, then you merge it to the last one. So then after separating, then we'll, for each of these new columns that we're creating, we want to take out any space that would be before or after the values. We're going to take them out. So that is what we're doing with the last mutate here. So that is that. So let me select this and run. So we'll get that now. So mind you, I'm not replacing the first data object. I'm creating a new one. And this is good. It's a good practice because you might want to go back because, like I told you, it's an iterative process. So we're going to definitely go back in time and say, okay, maybe I need to do more. Maybe I need to add more columns or something. Or what I did, the way I separated is not okay. Then I would have my raw data there still kept intact that I can use. So that is why we want to use a new name for the data object. So that is this. So now for the next thing that we want to do is that mileage still has something there. It has space and the kilometer after the number. So we want to take that out. And that's the next thing that we did here. For this one, so tags underscore mileage. Now we're replacing the KM with nothing. Then we're also replacing any comma or whatever, just trim it. We'll trim the spaces, everything. So we'll take it out. So then if there's any, we just replace it with nothing, then we'll convert to numeric values. So I'll quickly run this. Then the next thing is this. We can still explore, look at what we have now. Then you see that we only have numeric values. And if you drop down this arrow, you can scroll down, then you see that tags underscore mileage now is numeric value. So that makes sense. And we are prepping our data in the right way for us to be able to do better with our model. So the next thing is that let's do some quick summary statistics about the data. Let's see what we have. Okay. So I'm running this. So if I scroll up, so we have the data object is cars. So number of rows is this, then the columns. So we have how many character columns? 17 and 4 numeric data type columns. Excuse me. So the next thing is we want to look at what is inside of these two groups. So for the character type columns, we want to look at the number of missing values there. So if you look at this body type and transmission, so definitely if you're following along well, you know that we need to just take this out a lot. There's so much missing here. But luckily for us, we did something smart by splitting this column. We also scrape this tag from the website so that we'll get more information, because having missing values of almost 44% or 45% is a lot in some instances, and might not be a lot in some instances as well. So you might want to maybe replace the missing values. It depends, but it's not an automatic decision that, okay, I have to take away any column that has missing values. No. So, but because we are fortunate, we have some columns that we can replace those ones with, then we don't have to bother. So we have these columns here, tags, condition, and this one. So that could easily replace some of these ones here. Then the condition now. So condition as well, okay, it's 100 Then tags is also 100. Yes, it's 100. So, okay, it's the transmission that is the culprit. Now I remember. So that is the one that we would have to take out completely and replace it with decimal. So the unique values that are there, just four. In condition as well, we have 3 unique values there, and so on and so forth. So let's just go now to the numeric values, or the columns with numeric values. So here also we have the engine size and the tags mileage having some missing values. But if we look at the ratio, it's not so much. So we can manage this as we move on. So we'll see how we can manage that very soon. So at this point, if you have any question or maybe any of this, why should we be doing this? You can ask that question at this point. So if you have any question.
Thank you very much. I have a question.
Okay, good.
Thank you very much. My name is Victor.
Okay.
I was wondering why those are categorical variables, right? Like transmission, is it condition? Maybe if we just scroll up and show us those ones. Those, I mean the outputs, the output of the summary.
The scheme function?
Yes, the scheme outputs, just for the character variables. Now, there are some of them that have, they are categorical variables. They have just 3 to 4 unique values. So I was wondering why didn't we coerce them into factor types rather than just leaving them as character? Or is that not something you do later?
Yeah, taking it one step at a time. We're going to deal with character types, and that's why we are first of all exploring the data. So, and when I started, I mentioned that we need to prep the data into a format that is good for our model. So all these steps are steps that were taken towards that end. And if I paste in what I have now, that is just going to be the answer to what you're just asking for. We're going to convert all the character types that were selected for the modeling, that we're going to select for the models. We're going to convert them to factors. So does that answer your question?
Yes, Ma, thank you.
Okay, thank you so much. So is there any other question? So if there's no question, then I think we can move on now. So, like I explained, there are some columns that we wouldn't really need. So, like I explained earlier, we don't want the listing ID, neither do we need the Toyota or the title, because we already have information about everything inside the title. So we're not going to select that. So, and so are some other columns there, because we don't need them. Then they have too many missing values that we actually don't want to deal with. We don't need it actually. So that is why we're going to drop some of them. So the columns that were particular, but that we feel would help our model handle or learn from the data that we're going to give to it, and prep it or prepare it or train it. That's the name, that's the word that you should use. Train your model to be ready to predict well on data that it has not been exposed to. So this is what we're going to do. So we're going to select some columns that will help it to be well stable to predict on future data or new data sets that we're going to expose it to. So that is why we're going to just restrict it to specific data like this, that is going to be of this name. So we're going to select the price Naira. That's the column, this column. So if you look at price Naira and price formatted, like I told you, I scraped this from a website. So they needed this to kind of present the information on the website. So they will need the Naira icon there, the commas to make it readable for viewers of that website or users there. So, but this is actually what we need, the price Naira. That is what makes sense to, that would what would be sensible to our model. So we don't need this formatted one. We don't at all. So we're not going to use that. So then the next one is going to be the make. The make is very, very important. The model, the year the car was manufactured, the engine size, the color, the tag, the condition. Now we're dropping the conditions column. We don't need that anymore because it's almost this is the same thing. Then the tags transmission has the complete data compared to the transmission column that we had there earlier. So they would have the tags mileage, which we have cleaned. We've removed the kilometers. We've removed the space. We've converted it to numeric value. So we're going to use that. Then we need to also have the state and the city. We wouldn't bring in the location because the location is having information about these two columns. So it's more like a repetition, like you just repeating yourself over and over. So we don't need the location column. So that's why we're dropping that one as well. So we'll just stick with state and city. So this is where we use the select function to bring in those columns. So if I run this, you'll see that now we're going to have something like how many rows now? How many columns? So it's 11 columns. So, and look at this, we're still having them as characters. So just like Victor asked, are we going to leave it this way as a character type and pass it like that to the model? No. But if I want to do that as well, I can do that because tidymodels has all the functionalities to make you lazy if you want to. So, but I'm not going to do that. So just clean your data. Clean your data, and when we get there, I'll show you the steps that you can easily do that there. But it's better, don't put too much on your model. So next thing is that any missing value that is in our the column, the main column that we're going to be predicting. So we have the features and we have actually the column that we're going to be predicting. So we're going to see that, okay, there are no missing values because this could be an issue. Okay, we don't want that issue here. So what else? So we're converting all the character types to factors. We already have all our numeric values as numeric values. The year is numeric, the price Naira is numeric, engine size is numeric, the mileage is numeric. So the only thing is the character types, will convert them to factors. So then we look at what we have now. So we have price, Naira as double, then all the character types that they are now factors. So I hope this answers your question. Now, Victor?
Yes.
Hello?
Yeah, thank you.
Okay, thank you. So let me put it. So now that we have everything ready, the data is ready. Our features are in the right shape. So everything is good. So we just need to do what? Split the data into the training data and the test data. Okay? So okay. So that is the next thing that we have to do. The reason why we're doing this is this. We first of all, we don't want to give all the data that we have to our model. One, we need to keep a set for training the data, get familiar with what we will give you in future. So this is what you're going to play around with this for a while. So then after the model might have gotten used to the training data set, then we'll now expose it to the test data to know that, okay, actually, did you learn from the training data or not? So this is what we did. That's the reason why we're splitting the data into two. And sometimes when we go further, when you are used to just splitting into two, you have to go into another stage. You want to split into maybe three for validation and stuff. But I don't want, let's just stay at the beginner's level. Although we are going to do some things that might be more than beginner's level, but let's just stay with splitting into two. So for now, so that is where we're going to go for this one. Okay. So these two, so initial split, if you look carefully at the screen now, it's used to split training and test set data that you can use to train your model. So if you want to know more, just use the question mark or you explore more about it on the website. That's tidymodel website. You get more information there. So this creates a single binary split of data into a training set and testing set. So the other one does the same, but takes the first this. So what we need is the first one, the initial split, and it's going to take our data, and the proportion that you want to split it into is either a percentage or a fraction. Then if you want to use strata, then you have a choice there. You can use it because this is what is going to be the values that we're predicting. So, and what else is there? So these other ones are not really important, except you want to go deep. So, but you can read more about it here. So, but I'm going to stick with the most common one. That is, I'm getting in the data. I'm going to state the proportion that I want. So the proportion is, how do I want the data shared between the test data and the training data set? So I want it to be, in this instance, 70-30. So that's 70% for training and 30% for testing purposes. So, and how do you want me to be kind of just in the splitting or sharing of the data? Yes, I know I'm going to share 70-30, but how do I make sure that, okay, I'm making it equal? Splitting here, and then we'll explore. Am I sharing my screen? Sorry, can you see my screen?
Yes.
Okay. So now this is our data split. Okay, you can see the icon there. So if I drop this, you will see a description. So it's more like a summarized information about your data. So it's telling you that your training data sets has 2,432 rows, while the testing data has 1,045. Then the total, if you add these two together, you'll have 3,477. So this is your split. So if you now want to save each of the training and testing data separately, which you should do, then we'll do this. We use the function training and testing to extract the data from the data split. So you get to see that that's going to get so they are just data frames now. So if you look at this is what we have, and the same thing here. So the strata in this sense is that is going to help this function to split the data in the sense that we don't have only cars that has lesser or they are not expensive, getting too much in the training data set or getting too or lesser in the testing data set. So they are spread evenly. For those ones with the expensive cars, the less expensive cars, they are shared equally between the training and the testing data sets. So that is why the strata is always there, so that we'll balance everything up. So the next thing is, so let me go in here, maybe. So the next thing that we want to do is that we want to do something we call pre-processing. So when we're looking at pre-processing our data, let me copy this. Well, I don't want us to take or lose our time here. I want to go through everything as much as I can. The recipe package will help you to do further pre-processing for your data. So you don't want to just say, okay, yes, I've cleaned up my data, but you have to still do some steps, take some steps to make it to be in right order. An example would be this. Let me see if I have this here. Now, a new script. So what I want you to understand is this: those steps are not just taken for taking sake. Like the price naira that we're going to be predicting, okay? It's a numeric value. The same thing with those ones that are factors. Numeric values, they need to be normally distributed. That's what, like having the bell shape. I don't know how many people are familiar with statistics, but it has to be normalized if it is not. So there are some steps that you can go through to do that, because that will really, really help your model to perform better. And that is where all these steps comes in. So if I take you back to the code that I just added now, we want to look at let's see how the data is spread with respect to the price name. There is the numeric value, and the only thing we can do is just let's look at the distribution. That's where the histogram will come in. So let me quickly do this. So just okay, yeah. So if you look at, I don't know if I'm sharing my chart. So if you look at the distribution here, you can a lot of the prices have clustered towards the lower prices. Very few are having high prices. So this is a long tail. We have the tail going to the right. That means it's skewed. Rightly skewed. We need to normalize it so that we have something like let me annotate this camera. So we need to have something like this shape. Sorry, I might not be able to draw better. So we need to have a shape like this for the distribution of your data, or the values for this price naira. So here, one of the common ways that you can use is to get the log. Yeah, it kind of apply log, the log function, get a logarithm to the base 10 of the values, so that we normalize. That's one of the ways you normalize. So if we go back to, let me clear this up. So if we go back to our studio, so here you can see that it's not normal. The data is not normalized, but if I apply this, if I apply the log on the price column, you'll see we'll get something different. when we plot. So now, if we look at the plot, we have something close to having a bell shape. Okay, where's the pen? So you can see we are almost having like a bell shape. The tail now is shorter. So the data is now kind of balanced in between. So it's not just falling onto one side. And this is where recipes comes in. It's going to help us to create like a step-by-step activities or tasks that the model should do before making any prediction. So you have to follow that formula. If you want to do any prediction or make any predictions on our data, do this, take these steps before you do that. So that is where, okay, sorry, there are questions. Okay, yeah, yes, thank you. I'm coming. Okay, if the outcome variable is categorical with the step, will the step not should be, sorry. Okay, if the outcome variable is categorical with, will the step normalize not going to be necessary too? Okay, thank you for the action. No, if the outcome variable is categorical, it's no longer a regression model, but classification, yes. So do you understand? So I think that should, Dante, has Victor answered your question? Hello, can you hear me? If you're still there, can you confirm if your question has been answered? Okay, so let's just look at the steps now. So the first one is the recipe function. This is where we lay the foundation for the recipe or the pre-processing of the data. So it's taking our price underscore naira, that's what we want to predict, or you might call it outcome variable. That is actually how you should call it, but just in a layman's term, this is what we want to predict. Now, what is this dot referring to? We're trying to tell the processing steps or the recipe function that, okay, here is what we want to predict, the price underscore naira, and here is the data that you are going to learn from. Because specifically, we are using all the remaining columns inside of this data. So this dot represents all the remaining 10 columns that we have in the trained data or in our data set. So if I run this, you'll see the outcome is telling you that we have a recipe, a pre-processing step, a foundation has been laid. Then the number of variables by row are, outcome variable is going to be 1, and which is our price underscore naira. Then the predictors, they are 10 in number. So, and this is where the dot starts. And we know that everything is coming from the train underscore data. So that is that. So the next thing is that we want to use the step underscore log function. So step underscore log function helps us to do log transformation of our outcome variable. That is the price underscore naira. So most of the time, like we've shown, data is mostly skewed. So in order to manage that skewness inside of our outcome variable, we want to apply the step underscore log function. So we are doing like a log transformation. So a log transformation reduces skewness and helps the model focus on percentage changes rather than raw differences. Okay, so you can see the tail is still there, but at least it's been reduced drastically. So, however, you just notice that there's an argument here. Skip is equal to True. So this means that the log transformation is applied during training only, but skipped when making predictions, because we're going to apply the same preprocessing steps to our test data as well, and also when we want to predict the outcome variable. We are referring to where we're using the test data. So that we can easily get results back on the original scale. So we don't want the values that have been transformed. So we want the original scale to be applied then. So this means that it's going to improve the model stability and interpretability as well. So, but we just need to be careful. We need to be careful there. So the next one is step underscore input underscore median. So this is where we want to manage missing values. We want to manage missing values in our data sets. Okay, so we are using this function to replace any missing entry or data or values inside engine size and tags underscore mileage with their median value. So we get it's going to get the median of all the values in the column engine size and tags underscore mileage, and use it to replace or place it in where any missing values are. So it's going to replace all the missing values. So that is that. So if you want to ask that, okay, why use median? So the reason is this: it is robust to outliers. So if like the extreme values that we have here, so this will cause out, these are some sources of outliers. So it's going to help us to handle those ones and then manage that within these two columns. So outliers are going to be handled better. So basically, it's more like, okay, maybe you have fewer cars with extreme engine size or mileage values. So the median would kind of, it's not going to, it's going to balance things up. It's not going to kind of be causing EA damage or something like that. That's just what I would say. So it's going to help better make the model that, okay, we're not going to just be dropping rows based on missing values, but rather we're maintaining a kind of stability within the data. And we're still going to get the actual, a good model, irrespective of if we drop or we're replacing with median values, because that's the way we can manage things. It's not the extreme ones that are having so many missing values or rows with missing values. So the next line here is step underscore mutate. So here we're just making sure that, okay, the year column stays numeric. It's not compulsory. It's like repeating ourselves. It's already numeric. But just like I said earlier, for the character, the columns of character type, if we decide not to do any changes to their data type, we can still do it here. So this where the mutate function comes in. So, but we've handled that, so we don't need to do that here again. So, okay. So the next one is step underscore Nobel. So this is going to help us to handle new categories in predictors that are of categorical values, that they have categorical values. So maybe in future, there might be a situation where some certain models or make, because that's some of the categorical values that we have in our data sets, maybe a certain model was not captured in this present data that we're using to train our model. But in future, in cases where new models or make comes in, our model will be able to manage that well. So this is where the robustness and the real world reliability of our model comes in. We need to be sure that, okay, this model will handle both present data, past one, and and they are ready for the future. So the next one is also applied to categorical values. So this is where we're looking at rare occurrences of some categories. So we're trying to see that, okay, any category that appears in maybe less than 1% of the data, we'll group them as others. This can also be done in while we're using some tidyverse functions, but it's still okay here and leave that within the recipe steps. So the next one is where we're creating dummy variables. So now we want to convert all categorical predictors. Now we've handled them from using these 3 steps, but we now want to convert them into numerical formats, because right now they're not in numerical format. But at this stage, we are going to convert them to numerical formats. So is like we are creating binary columns for each of the categories. So that the machine learning algorithm or our model, okay, we said it at the beginning, our model needs numerical values or inputs. Is expecting numerical values. So we're going to now interpret the categorical data or convert them into binary columns that are now in numerical, they are having numerical values. So the option here, one hot encoder now ensures that we use full one hot encoding. So we don't want to reduce dummy encoding that drops one level. We want to capture all the levels. So the implication is that the model, which is in this case is a regression model, or maybe we're looking at tree models based on trees, and so on and so forth. They can handle categorical features better. So and this will increase it can increase the number of predictors, definitely. So if we're looking at 10 columns and we're converting into binary columns, we might be looking at something like more than 20. And like 20 plus the other columns that are there. So that'll be something like 21. So that's what we'll be getting back. Okay. So the next one is step underscore ZV. So this is where we are trying to remove zero variance predictors. So what we mean by this is that we want to be sure that, okay, all predictors that have zero variance, they have the same value across all observations, like they are balanced or they are not kind of interfering with each other or something like that. Maybe that's the only, because this is like in technical steps that we're taking. So any feature or all the features that have zero variance, they don't really contribute any useful information, and keeping them can slow down training or sometimes distort the model interpretation. So we need to really keep them in check. So this means that the data set is okay, and then we ensure that only meaningful features are passed to the model. So all these steps are what we will have here. So we don't want to just, that's why I said, yes, we've done some processing, converting from one type to another, removing the missing values and all this stuff. we still need to do some processing. And these are processes kind of directly related to how our model functions, not just about data. So how the model functions. So the last, but not the last one, and surely the last, okay, is the step underscore normalize. So this is where we normalize all numeric predictors. So that means the scales for all these predictors are the same. So, and it means that they were going to have a mean of 0 and a standard deviation of 1. And that means we have the bell shape. So, that's basically what I would say. So, um, generally, normalization just ensures fair contribution of all numeric values to the training of our model. So if we have some values, maybe numerical values like $100,000 or 100,000, not even there's no dollars or anything. It's just number. And we have some columns where we are having values ranging from 1 to 10. And still numerical values. They can affect each other. And that's where we need to normalize all these values. So that is for this one. So I think at this point, this is how we are going to pre-process our data for modeling, not just for analysis or just getting the data, but this is key or necessary for our model. So let me run this. Do we have any cheat sheets to tell when and when not normalization is necessary? Okay, I think the only cheat sheet that I can give to you is for you to do your EDA properly. That would lead you to determine or decide if you want to normalize your data or not. Because last one, let's look at what the output is going to be like. So this is it. So this is the recipe. So what is here is more like step-by-step instruction. Is maybe you are a guest in somebody's home, and they give you step-by-step instructions on how to live in their house, because the rules you have in your own house might be different from what they have in theirs. This is more like a rule that your model has to follow. So first you do the log transformation of all outcomes, and we just have one. That's the price, Naira. Then median imputation for missing values here, and so on and so forth. So let's just try and move on well. So that's the rules there. So let me go back and just so we can do something here. I'll explain these aspects. So in order for you to test out what would be the result of these rules being followed, you can apply this to your data. Okay, so we can do this. We can run this and then bake. We're going to use just ordinary generalized data for our training data. So we've already applied that here because this recipe is based on the training data. But we just want to see kind of what is going to be like. How is the data going to look like when it is being exposed to the instruction here? So that is it. Because this prep and bake, they are automatically applied when you fit your data to the model. So logically, this is what you're going to get when you apply these steps. So this is what you're going to get. We have so many. It's like, what would I say? All these values are based on statistical operations, like probabilities. Like that's just what I would say. Probably by or something like Aquira or something. All these are just statistical values. So it's not going to just use are poorer like that. And you can see it's not just the column, it's now the column and the values, the columns and the values, because it's now dealing with all the unique values inside the make as if they are new columns and they have different values for each of the rows. So it's a lot now. So from how many columns? I think 11 columns. Now we have 121 columns. Then we have 2,432, just like what we have in the training data set. Excuse me. So that is what you will get. So let's just clean up this place a little bit. So this is it. So I'll be a little bit fast here. So I did some work, but I will just show you that if you're going into modeling, you need to start with a baseline model. That is like something basic. So we're not going to be specific, just the normal linear regression model. And this is where the first one comes in. So when you create your base model, this is where you now create more advanced model that you can now compare which one performs better on your training data set. So if you now see which one performs best, then you now select that model. So you can create as many models or want and come up with the best at the end of the day. Maybe it can be your random forest, because random forest is going to do linear regression, but in a different way. Okay? In a different way, we're talking about trees having branches and all this stuff. So this one, I'm not going to go deep into it, but this is something that you can go more, research more into. So we have random forest, we have glimnets, this is SG boost. So different models can be used for linear regression model to create linear regression model, but we're going to stick with just two today. So let me go and run this. These are base model, then this one. So the next one, so whatever. So now the next thing is, let me just take this. You need to do what? Create a workflow. We have different pieces now. First, we have our data. Then the next thing is that we need to create a workflow. A workflow is that is like a document, like SOP, that your model has to follow. First, you transform it into an SOP. Then you add the steps there. Okay, first you add the recipe. That's the standard you have to follow, like the steps or procedures that you have to follow. Then you are going to, after applying this to the training data set, then you use it with this model. So that is the base model, a baseline model. That the second one, that's for the random forest. So so around this, sorry, I'm just looking at the time. I don't want to take too much time there. So then, okay, like I said, we're targeting beginners, but you have to get used to some tough things that you have to do as well to get something better. So cross validation here of folds is, yes, we know we've split the data, but we also want to now take that data and randomly split it again into folds. So that it's more like we're playing with cards, card game. I don't know the name again. When we play with cards, you know the way you shuffle stuff. That is exactly what you're doing here. I don't want to use any technical terms, but I want you to understand from this that, okay, yes, I've split into 70-30, but that 30, that 70 now, I want to kind of make my model strong enough that I will be shuffling the data and asking it to work on those data. As I'm shuffling, do it again, do it again, do it again. You're going to get better. That's more like that's what you're telling your model. So that is what I see, and the most basic way of explaining how to do cross-validation. Yes, I've cleaned my data. I've transformed it. I've created new features or columns. I've also created a standard that is the SOP then that is going to be used. Then after all this, I still want to make sure that you're not just cramming every data that, okay, this is number one, this is number two row, this is number three row. No, I'm going to shuffle it again and make sure you don't just force yourself to cram the data. No, just learn from it. I'm going to train you to understand, irrespective of which one comes first or which one comes last. And that is where this one comes in. So I'm going to kind of create cross-validation data, and we'll use it on the model as well. So please, if you have questions, there's somebody in there that could help. And then you can just put it in the chat. I know you'll get somebody to answer there. So please just do that. So for the baseline model now, let me bring in the data here. So this is it. So I am using this function. It's more the same thing like the fit function, but we're resampling based on the folds that we're creating here. So this is going to help us train the data. It's like training the data. We are fitting our model to master or learn what is inside of our data by doing some shuffling as well. Then how do we now know that, okay, the model is really doing the job of learning or training on it? We have some metrics that we want to look at. So this is where the RMSC comes in, the R squared, the MA. So all these functions, they are still coming from the tidymodels package. It is an all-encompassing package that helps you, guide you through all the steps that you need to create a good model. There's no perfect model. So that is where this one comes in. So then you're controlling, so say, predictions and all this stuff. So I don't want to choose too much, but I need to just use that. So we're collecting the metrics now. So don't worry about this. So it's just a warning, and there are some things that I did in outside of this class that takes out that. So we have the three metrics here. So if we look at the metrics, it's not perfect. It's really not perfect. We can explain using the model that we have, the explainability of the learning from the data is low. That's like 46%, something like that. So just let's know that, okay, our model is not really perfect. So it's not perfect, like, okay. So if the mean stays MAE, is this value is high. And I know we have extreme values there. There are some Tesla cars there. They are very expensive, very few of them. And that's why these ones are going higher. So this value is low. So we'll just pick the best when we're moving forward. So let me just go in again. So for the second one, the second model that we used is random forest. Let me bring that in. I think this one will take some time, but I will use that time to answer any questions if you have. So I'll just run this because this is the one that we want to look at to compare with the base model. So so this one, and then just see how. Oh, okay, sorry. I need to run this. So let's hope this runs fast, and it's going to take some time because data is large. So if you have any question at this point, please let me know. So I got booted out, so I lost the message. Okay, so welcome back. So if you have any question at this point, please kindly let us have the question. This is going to take some time. Okay, it's going to take some time, and I'm hoping that we'll be able to use the time well. So if you have any question, please kindly raise the question. So, but the next thing, after we've trained our model, we're going to, like the random forest model, from what you've seen, it's based on tree-like stuff. Okay, how do you decide the number of trees with RF model? Okay, the way you have different ways of this making your decision. You can do something static, like you can say that, okay, maybe your tree should be here. The first one that I use to tune the random forest, okay, I gave it a static number, okay, like 10. So if you're not comfortable with that, like, okay, go ahead, Victor.
No, I wasn't interrupting. I have a question when you finish with this one.
Okay then. Okay, so you can use a static value. It's not written on a, it's not, yeah, like your question says, you can decide to use a static value or you make it flexible, like the features that you want. The tree shape, the tree stuff structure is based on the number of features that you want to use for each trial, for each tree or something. Then it's going to now try maybe between, okay, let me try two, 4 or something, 4 levels. And this is going to be what is going to follow between 2 and 10. Then this one, the minimum is this. It's still the same thing, but we don't want to go out of that scope. So based on 4 levels. So if you create this grid yourself, this one is flexible compared to this one that is static. So that is why I'm using this one to decide on which one should be used. I don't want to hard code it. So, but it's okay if you want to make it 10 or 5, whichever one you want to use. So that is basically what I can explain there. So if anybody had any other opinion, as simple as you can explain, please signify. Then we have the output now. You can see this is the first trial is between 10 and 2, 10, 4. The minimum is 4. Right here, the minimum is 7, 10, the 7, 2, and all this stuff. So all these ones are what we're going to now look at. Which one is the best? So it depends. So it's going to show this is not all, but you can see the numbers here. This one is 13, 14, 15, 16, 0, 9. So these are not all the trees or the models that have been that were from those trees, those trees, as we will say. So, but these are the best for now. These are the best. So that is what we have. So please go ahead, Victor, and ask your question.
Yeah, in the step of when you were selecting the variables that were to be part of your model, the way you were showing us, you were doing it like it was more of by eye. You were looking at the summaries and then deciding which variables you wanted to keep, in the model. Is there a way that this can be done in a more structured manner, maybe some kind of methodology where maybe you have maybe thousands of variables in your model? It'd be difficult to do that by eye. Thank you.
Yeah. Thank you very much. That's an excellent question. And okay, let me just keep the aside. So what he's trying to say, we've not gotten to that place, that stage there, and I might go through it quickly. So the way you can get the most important features. This is just like a basic way of selecting the features you want to use. The predictors now. So I can logically look at this or do some summary statistics that would help me look at the correlation of all these things. And I can, as a layman, say that, okay, from what I've learned from machine learning, from what I've learned in class, I've looked at the number of missing values, I've looked at this and all this stuff. I don't want leakages. I can decide on the columns that I want at the early stage. And that is what I'm using to train my model. But that's why I said also that it is an iterative step, or it is an iterative process. You're not going a one-way traffic. You're going to go round and round and round until your model is close to being perfect based on some metrics. So if I start with 11 variables now, that, okay, logically, this is what I think should go in there. When I first get my model and I look at these metrics, okay, and I believe that, okay, I need to look inwards again. Which of these columns or features are actually having the highest impact on my model's predictive power? The way I can do that is by using this package, VIP. Okay, so this will help me to look at all those features and come up with which one is the most important one. Okay, so that is where, let me go quickly to answer that question. Sorry, it's a lot of time, but but I want the steps to be as clear as possible. So that is where, but to answer your question, we're close to that stage. So now that we've been able to choose the best mode, the best one now, the best one based on the RMSE value, the best model out of all the models that have been created based on the trees that were generated is the one with the name model 13. Let's just say model 13. So it went with M try of 10, the minimum was 2. So that is the best model based on that value. So it's going to look at the RMSE value, the values there. Let me go back up here. So it's first of all going to look at the mean. Then we'll look at the standard error. So which one is the best? So you can see 13 is actually at the top here. So if you think that these two are the same, no, you have to, that's where this one, the ones that I comment out here comes in. And you have to just go deep in and look at the decimal points. That's where you see the difference. It might be very, very minute, but you see the difference there. So going back to now seeing which one is the most significant features. This is where VIP comes in. Let me go directly there. I'll come back to this one. So this is where we've created our final model here. We fitted it. So let me just run this one quickly. I would go back there and explain, but the question is this: can I know which one is the best? So let me just stick with 10. So now what I want to do is this. I'm extracting the model, okay, using this function from the fitted model here. That's the output. So if you take this, run it, then you see that, okay, we have the resampling results here. It's manual resampling and all this stuff. So based on that, we've extracted the model. Then we will now go into that model and say that, okay, which ones are the most influential? Okay, no, sorry. Let me run this. The most influential is now going to show you this chart. So at the top, the most influential feature here is the year that the car was manufactured, this one. It has the most influence on the predictive power of your model, followed by tags, condition, especially local use, that value. Then mileage, followed by condition again. You can see condition, tag condition is very important. Then followed by the engine size. Then make. Then another thing is city, which is Lekki and other stuff. So, but if you want to now decide that, okay, I want to retrain my model, which is somehow brown out, but you go into your model again, create a new model, and now restrict it to just this top 5. One, no, okay, maybe we'll say year, tax condition, then mileage, then engine size, then make. So we'll stop there because city now is kind of biased towards Lekki. Maybe most of the cars that we have on that website are coming from Lekki. I don't know. In Lagos, I don't know. So, but I would say the list would be city. Then this ones I just make some decisions here. So, and I'll still repeat it again. The process of creating your model is iterative. So let's say I said, okay, because of the chart that I have here now, I'm going to go with the first 5. And I train my model. If I see that, okay, maybe the performance is not that really good, I can come back and decide to take any of this again and join it, add it to it, and so on and so. So you go over and over and over again. That is how you just continue to train your model, create more models until you get it close to perfection, not perfect. So does that answer your question, Victor? Hello, Victor?
It does. It does.
Okay, thank you.
Thank you.
So so that is the way we get to, after we've fitted our training data to our model, then we'll come with this, we can save it, then we'll look at the most important ones, then we'll go back and start all over again if you want to do that. Then we can compare our models here. So let me just go through now because we're running out of time. So let me see if we can get something here. If I've not tampered with anything, yes. Now let's take a closer look at the charts now. So it shows how well our random forest model predicted the car prices. There's a price underscore Naira. So compared to what we had actually with although we didn't show the chart for that. So, but this is the explanation. You can see on the y-axis, we have the actual price from our training data set. So then we have the predicted price from our model. So that's from the random forest model. So what you see here is that each of the dots represents a cap. Okay, so that dot is showing us on the x-axis, it shows the predicted price. So by our model, then on the y-axis, you can see the real price there. So that is what is there. So basically, if we look at everything, the line that you're seeing there, the red line, that is where all the points are supposed to fall on. So it's supposed, the line represents where whatever that the model was really 100% perfect, which we surely know that, okay, that's not going to be possible like that. So then if it were perfect 100%, all the dots that you're seeing there on the chart, they are all going to fall on the line. They are all supposed to be on this straight line. Okay? So that means that the predicted price is always equal to the actual price. So, but in this case, there is not really that case is not a perfect model. So we can see that most dots are closer here. Let me annotate this. Most dots are closer here to the line. Let's say up to this point, something like that. They are closer to the line. So that means, especially for the lower prices, because here where we're seeing the lower prices. So the model did a good job. It did a good job predicting the price. It's better. But as we're moving up here, let me change the color. As we're moving up here, where the prices are higher for the actual price, the predicted price are not really falling in place with the actual price. So the dot, you can see that this dot are now spreading apart. So the model is kind of struggling to predict the prices for the expensive cars. So, but for the lower price cars, it's doing a great job. But here, no, it's not doing a really great job like that. It's not perfect. So it's not really good. So here is a better score for the lower prices, but for the higher prices, it's not really good. Less accuracy is here for the higher prices. So that is what we have here. So we should just know that, okay, the model is good, but it's not 100% perfect at all. It's not 100% perfect. Summarily, I've been able to take you through the steps that a data scientist or a data analyst, because don't say that a data analyst will not create models. No, they can. Even right now, you can't do that. So as a data scientist or a data professional, you want to create a model, you should know that first, you need to understand the business case behind why you have to create a linear regression model. We want to predict, let's say we are a company that sells cars. I have a company that sells cars and I've employed you or contracted out to you that you help me create a model that if I get a car now and I want to sell it in Lekki and the car is Toyota, is blue color, can you create a model that I can use on my website that will give me a close to perfect price for that car? So that I don't just because maybe I went abroad and maybe outside imported it so cheap. It doesn't mean that I have to send the car cheap. I can make more profit if you create a good model for me to be able to make that assumption. You can even bring external data. It doesn't have to be just what I have here. You can bring in data based on inflation, on trends in the city, in those cities and all this stuff. You can bring those things in, those data in to help your model perform better. So this is what we are going to do. That's the business idea behind this. Then you get the data. When you get the data, definitely your data will not be in the right way. I got all this data from the website. I had to do some cleaning. And I've shown you some of the cleanings that we did. So based on after that, then you need to know that I have to look at some statistical information about the data. Based on that, I will now decide on which model would I create. First, I'll start with a baseline model. That's something basic. Then this is what I'll now use to benchmark to other models. Before going too far, then I need to prep the data as well. That is where the recipe package from the tidymodels comes in. That's the first thing. We split the data. we split. When we split the data based on some criteria, proportion, the strata, then we'll go into creating some rules that our model will follow. That's where this recipe package comes in. The next thing is this. We'll explore what the recipe does. We look at that. Then we choose our model, the baseline model. Then which other models that you want to use? You can use XGBoost, random forest, and so on and so forth. So we create a workflow. all these steps are separate. They are separate entities. You need to bring them all together. And that's where the workflow function comes in. When you use the workflow function, then it brings compact everything, package them together, then we'll be able to use that. Your data has been splitted into two, but that doesn't mean that we can't do some little tweaking or even rigorous tweaking by creating some cross-validation folds. That's like shuffling. So that it just doesn't matter that, okay, row 1 is for Toyota Camry, row 2 is for Honda Accord, and the row 3 is for Tesla, row 4. So that we don't want that to happen. So we want to shuffle the data and make sure that we train it very well to master the data, irrespective of where the row the data is, which row, whichever one. So that is where this one comes in. Then we fit our data to our models, collect the metrics, decide on which one performs best by comparing with the baseline model. Then we look at the best ones, we decide, and then after we've gotten the best, we are not done yet. We will now look at which of these features actually created this best model. We'll look at the importance of each of the features, and that is where the VIP package comes in. The VIP package will now help us to do what? To decide which one of these features should we use for training another model. So we can decide to juggle any of these top 10. In this case, we went for top 10, then we'll decide which one we'll finally settle for based on the metrics. So with that, we can now use that final model at that stage to predict on our data. So if we predict the data, we don't stop there. We compare with the actual price. And the actual price, we visualize that and see, is it really level of the predictive level power of the model. We don't say that the model is perfect, but we have to get it to a state that they will be comfortable using it. That is just it. So if you have any question, I think this is where we're going to stop. We're close. We have 10 minutes more. So if you're having any question, then please let me know and I'll be able to attend to that. Any question? So while I'm waiting for any question, I would like you to understand that the code and the data, they're going to be shared with you by email. Then we're also going to share it on our WhatsApp group. So if you have further questions, you can share with us on the WhatsApp group. We'll be able to attend to them there. So at this point, I want to really appreciate all of you that have stand there with me all through. So this is an interactive session. It's not a kind of a formal setting. So we just want to introduce ourselves, talk us through in as much layman's term as possible. So we're not in a restrictive class. So that is where this one comes. So it's not formalized at all. It's just want us to go through it and understand. So if you have any question.
There's a question in the chat.
Okay, let me look at that. How do you decide number of? Okay, I think we've answered that. What do you recommend to understand how to make predictions with this? Thank you for this, Bilikisu. Okay, sorry, predictions with this. Are you talking about like price prediction numbers or what? If you can be clear on that question, I would appreciate that.
Well, why not put on your mic and ask it verbally so I will understand the question.
Exactly. Please, you're free to talk. Okay, you can talk.
Yeah, for me, I
So,
think
but okay,
the way I understand this question, maybe he or she's asking what are other maybe practical uses for this kind of thing. I don't know. Maybe it's
okay, okay. If that is the case, so there's so many kind of instances where you can use this kind of linear prediction, especially when you are trying to predict numeric values. Like, okay, price predictions. Okay, there's a question there now. Okay, I've been using R, but would love to learn more. With you. Okay, awesome. You know what? One thing is this. I actually want to go further into comparing the old way of creating models with tidy models. I would have loved to get to that point, but we are short of time. But maybe I can create a video on that using this same example. The beauty of tidy models is if you've used tidyverse, you would appreciate using tidy models. Tidy models gives you a structured way that you don't, it's more like you are in a supermarket that you can get anything you want in the world about cooking food. Maybe you want to cook jollof rice. I don't need to go. Maybe I'm in a supermarket now and I'm thinking, okay, can I get chicken, raw chicken inside the supermarket? Yes, you can get it. Can I get pepper here? Yes, you can get it. Tomatoes and all the ingredients. Everything that you need to create a model, you get it with tidy model, irrespective of the type of model that you want to use. There is a kind of an opening for you to use it. Like if you want, you can create an ordinary linear model, that's linear regression model. If you don't want to just create ordinary linear regression model, you can use XGBoost. There's another pipe for you to use that. Do you understand? So you don't have to go out and say, okay, let me create a function that will help me to do XGBoost and bring it and now combine. No, tidy models gives you a pipeline, understand the language of XGBoost. It understand the language of R, random forest. It understand the language of H2O, whichever one you want to use, you can use it within tidy model. You just need to understand parsnip. So this will give you like it understand all the languages for any model. That's one beauty. Then it easily integrates with tidyverse, the pipes. So all those layers, they are there. A one-stop shop for more. Yes, thank you, Charles. It's a one-stop shop. And all the processes, parboiling your chicken, whatever, prepping your pepper, everything you do with jollof rice, you can do it with tidy models for all your models. The recipe package is there, the yardstick for your metrics, the tuning of your model, everything, they're all available in tidy models. Okay, the workflow function is more like, what would I say? It's more like something that is, yeah, it helps you to bring everything together, like a one function that combines everything. Like for your recipe, it's combine it brings it in. It like a box. Yes, let me use a box. Workflow is like a box that has space for each of the stages you go through to create your model, like the recipe, bringing in in which model are you using, the data and all the stuff. So the model itself bringing everything together. I think that's what a layman's term I would say about workflow. But one thing that is the only statement here is that what Charles says, a one-stop shop for models, simple as ABC. Everything you need is there. It's for you there. And there's a book as well. Let me see. Okay. So thank you, everybody. I think we're running out of time now. So I want to appreciate everybody, and we're really grateful that you're here. We're trying to share the little knowledge that we have. We're not master of all, but we can share the little things that we know with each other. So if you have maybe some level of our expertise, no matter how basic it is, you can reach out to us and also try to share your knowledge. We are open to learning, even if it is just to read our package that you understand. Please join us to share your knowledge, and we'll really appreciate that. Thank you, everybody, for joining me today. And on behalf of the Abuja R user group and our lead is Abuja, thank you so much. And it's going to be a goodbye from me. So thank you. Bye-bye, everybody.
Bye.
Bye. Thank you. Thank you. Thank you, everybody.